by 10. 30 divided by 10. Yes, please share if you want, or a hot dog. That's fine too. You're very kind to participate. What?
Thank you, Dale.
That was good. Thank you guys. Thank you for playing. If we need more, I've got a bag of them up here. We need more flavors. There's some called mystery flavor. You won't have to be too keen on those. This is blue. Usually. That's a word we didn't put up here, did we? Usually. Usually. That's another good word, isn't it?
What about sometimes?
Sometimes, believe it or not, sometimes ties more over here. Believe it or not. And we'll talk about more as we go through tomorrow. Okay. Very good. Thank you, Nick. Now, friends, now that we're done with that little experiment, we now know how many they had in total, yeah? They had 30 in total. You guys had 30 in total, obviously, because 10 of you had 3 each. But the point of not letting you simply add up in the beginning and then divide by 10 was because I wanted to get at why that formula works. I'm not saying the formula is bad. The formula is gorgeous. The formula for an average, I'm going to take this out temporarily in 24, 48 hours and bring it back. Because once you have this makes a lot more sense. The formula for an average, well, first of all, I want to give it a special name. It gets used all the time in statistics. X bar. Okay, this is called a sample average. X bar. That's how we read it. And it's a way to stand for the sample average value. X bar. We use this guy, I would say, daily in Math 244. We're going to use him pretty much daily as we go through Math 243 as well. There's a population average too. I don't want to talk about him right now. I will come back to my promise. Why do I not want to talk about him right now? About your population. Remember your population? We spoke briefly last week about the population versus a sample. What's the problem with talking about a population average? You can't get it. I mean, you'd have to get your entire population. Very, very, very more common is that you have a sample. And it's very easy to find the average of a sample because you have it in front of you and you can actually do it. So the formula that you guys have always learned is add up your data and then divide by how many you have. And I don't want you guys writing that down when you're using formulas. We're going to use very, very few formulas in this class. I don't like coming at statistics as a formula-driven course. It's funny that when I talk to people, I've talked to people for 20 years about statistics, and they always go, oh God. They call it sadistics. I mean, they all kind of... And I'm like, what was so terrible about it? I'm like, oh my God, the formulas. And it's always that. That's what drove them nuts. It felt like a physics class to them, where everything was just what numbers go into what formula. I'm like, well, let's just make the course not have a whole bunch of them, but still get the same topics. I'm like, oh, that sounds like heaven. But here, this one here is crucial to almost everything. There's 2 formulas I want to make you guys learn in this course. One right now and one in about 9 weeks. Because everything else can be done way more effectively in other ways. So, because this one gets used so much, let's develop a shorthand for it. I don't want you writing this all the time. Greek letter, capital sigma. Can we check the camera? Make sure we can actually see this. That's probably back too far. Let's slide this. Let's make it usable for those watching it. That's better. There we go. Capital sigma. This is the Greek letter for S. Whenever you see that mathematically, it means to add a bunch of stuff up. So that's add up. Data, we always just use the letter X for data. Although I lied to you, sometimes we use Y. Sometimes we use X's and Y's. But let's not get ahead of ourselves. We're going to talk about X's right now. So when you see sigma X, it means you're adding a bunch of X's up. That's all that means. Whatever you've got, add it up. Okay, fair enough? And we add other things too. Sometimes we'll add things called frequencies, sometimes we'll add products, but big sigma just means to add. So this symbolically means the same thing as this does English. Divide by how many you've got. A sample size is usually represented by a lowercase n, whereas a population is arrived at by an uppercase n. Now, how does this formula beautifully wrap up what you guys did with the experiment up here in the lollipops? Because clearly, if we had plugged these 2 numbers in, we would have gotten 3, yeah? If we summed up all the x's, well, you would have gotten 30, exactly, and we would have divided by 10 to get 3. Why did what you guys do exactly the same thing that that's telling us how to do? And I think, Veronica, right? Veronica was hinting at it, and Nick echoed it from back in a different way in the back of the room. What were you guys doing?
Evenly distributing the data.
Evenly distributing the total. That's exactly what an average does. Some people call it a fair share measure, and I love that idea, the fair share. I mean, that's really what it is. It's a fair share. Now, it depends on how you define fair. Maybe there's a reason, Jessica, is that right? Maybe there's a reason Jessica had 0 lollipops. Maybe she didn't do her chores. So then is it a fair share that she gets 3? Well, maybe not. Maybe not. But fair share, maybe not fair share, maybe equal share. Let's change it to a I think the word equal is probably better, equal share. Although I've often heard it called a fair share. Maybe
How is that though?
Equal share? Because you all get the same amount.
Right, but if somebody didn't do something.
Oh, I'm taking the fairness out of it now
Okay,
by doing this. That's why I thought equal share might be less subjective, more objective. Every one of those 10 people got an equal share in the pot, so to speak, if that makes sense.
That does.
Yeah, that way it doesn't matter if they earned it or not, they still have an equal share as everybody else. It might not be fair, but at least it's equal. So I'm trying to remove that subjectivity a little bit from it. Is that fair? Is that understandable? Is that equal? So yeah, that's what this does. It takes the whole pot together. It ignores the fact that some of you had like 6 and 7 lollipops, I think, when you started, and somebody had 0. It ignores all those differences. Standard deviation that Pat mentioned earlier does not ignore those. That's why I want to come back to it next time. I want to focus on one thing at a time. It will not ignore those differences. It will measure those differences. Linda, go.
That might be a stupid question, but can you repeat what that E's mean?
It's not E, it's sigma.
Okay, sigma.
It means to add up. Whenever you see that in mathematics, it means to add a bunch of stuff together.
This one is
Fair enough. No, it's a good question. It's a good question.
And then X is what you're adding.
X, exactly. X is your data, whatever your data is. Okay, in this case, it's lollipops. I want to add some more data to the mix. Remember the keys data I collected last time with you guys? Here it is. Oh yeah, it's been a while.
Oh, I remember.
Sorry. Let me find it. Okay, here we go. That's what you guys told me last time. A
lot of people in the second class have a lot of 2 keys.
Yeah, it's nice looking at the difference, yes? The differences in the keys, good? Good, you found your own.
Nope.
So here's what I want to know. On average, how many keys did we have? You guys. You can ignore 10, 15 if you want to. Take some time right now and figure out on average. I wouldn't recommend, in this case, doing the share thing. Like, I personally wouldn't go like, okay, so 13 is obviously too many. Let's take like, I don't know, 9 of those away and then give like 2 and 2 and 2. Those should probably be zeros. That's typed wrong. Sorry. Those should be zeros. Let's fix that. There we go. That makes me a little happier and more sense. I put them in order intentionally. There, that's better. So take a few moments right now. I wouldn't do it with the share because A, it's too annoying, and B, I'm not even sure it divides evenly because I haven't done it myself yet. So let's pause this. So you all at home playing the home game can see the number of keys. There you go. And we're doing the 815 class, so we can just focus on that. And